right, so on 3.1.2, it is increasing the difficulty of it. So it says identifying terms in expressions. So what happens if they're more complicated? So in today's lesson, you're going to continue to simplify expressions using the correct order of operations. You're also going to learn how to identify terms in the expressions that are more complicated. So again, a big idea to take away from this section is how to be able to identify terms, which will allow you to follow the correct order of operations. So for 3-12, we're going to read it, but I'm not asking you to actually do this. I don't think we are at a good spot for you to do diagrams for exponents. That to me is not something that we are at a spot that we should be doing. But we are utilizing this problem for the next problem. So 312 says, for each of the following expressions, draw a diagram that could represent the expression, and then to simplify the expression. So those two expressions are the opposite of 3 plus the opposite of 4 groups of 2 to the third power plus 5. So again, we're not at a great spot to draw this out as a diagram with Cecil or with integer tiles. The other one that they expected you to also be able to draw and simplify down to one number was the opposite of 3 squared plus 4 groups of -2 plus 5. So again, I am not asking you to draw those out nor to do anything with it other than to use it for reference for 313. 313 says Katrina and Madeline were working on problem 312 when Madeline noticed these two expressions look almost the same, except for one has 2 terms, while the other has 3. Discuss Madeline's observation with your team. Explain which expression has 2 terms and which has 3. And then it gives you the definition again. This is the 3rd time that this definition's been provided for you in these 2 lessons, just so that you're aware. And again, if I ever come across a blue hyperlink word like this, I can open it and it will give me a definition. However, I like this definition probably the best, and it is terms and expressions are separated by addition and subtraction signs. So we already know, and we've seen many times, them being separated by addition signs. Subtraction is the inverse operation, or it undoes addition. So those two are connected. But the big change in this one is unless those 2 things, the addition and subtraction, is inside parentheses. Remember, the whole purpose of parentheses is to change the rules. They're rule breakers. So addition and subtraction separates terms unless they're in parentheses. So we're going to look at these 2. They're on your, these 2 expressions here, and they're on our notebook as well. And we're going to circle the terms on those and identify which one has the 2 terms and which one has the 3. So right here, again, I know that addition and subtraction separates my terms. So this is a subtraction sign. That's the opposite sign. So I have my 3. My addition sign stops it. But we have the opposite of 4 groups of 2 to the third power. So as a reminder, an exponent is repeated multiplication. If I was solving this or trying to simplify it, I would multiply 2 times 2 times 2 and then make 4 groups of those and then do the opposite of that. I'm not asking you to do that, but just to recognize that this whole thing right here is one term. And lastly, we have our 5, because again, we need to have a term on either end. I call it my expression sandwich. So I need to have bread on both ends. So expression A has 3 terms. Now, by default, that automatically means that expression B has 2 terms, but let's see where they are. So we have the opposite of 3 squared plus 4 groups of the opposite of 2 plus 5. So I'm going to circle my 3 squared because I know that's 3 times 3. I'm going to stop right there because I have my addition sign. And then I have 4 groups of this. So normally students, there'll be a few students who try to circle in here, sometimes even the 4 groups. But remember, parentheses change the rules. So this whole thing right here is one term. So we're going to write two terms for b.